Hi, I'm Nadav Shemer for our 2022 Tailings program brought to you by Mining Journal and Mining Magazine. The transition to a cleaner, greener world will require the mining sector to produce more raw materials than ever before. For example, lithium demand is expected to grow sevenfold between 2020 and 2030, according to McKinsey, and copper demand is expected to double between now and 2035. That's according to S&P Global. While the commodity is great news for the industry, it also poses huge challenges, including how to handle much higher quantities of tailings. And challenges associated with tailings include operational risks. We're all familiar with the collapse of the Brumadinho tailings dam in Brazil, which killed 270 people and destroyed more than 1 million square meters of forest, as well as many other recent disasters. Environmental impacts, including impacts to biodiversity from water pollution, as well as high water usage needed to treat tailings, and also the complexities and costs associated with meeting social and regulatory requirements, including the Global Industry Standard on Tailings Management, which was released in 2020 in the wake of the Brumadinho disaster, and to which many major mine operators have committed. This panel discussion will look specifically at the role that new technologies can play in helping mine operators address and solve these many challenges associated with operating tailings facilities. Our expert panelists are Ken Rahal, Director of Tailings Solutions at multinational engineering firm FLSmidth. Dan Leybourne, Product Owner from Shell at OREN, a partnership between Shell and IBM, offering digital solutions and services to help companies in the mining and industrial sectors achieve ESG goals. Their portfolio includes a tailings solution. And Dr. Priscilla Nelson, E&O Director at the Tailings Center at the Colorado School of Mines Department of Mining Engineering. Welcome, everyone. I'd like to begin the discussion by exploring to what extent mine operators can fall back on existing technologies to operate, manage, and mitigate the many risks associated with tailings. And on the flip side of that, how critical is it that miners embrace new and smarter technologies on tailings? Dan, would you like to kick off the conversation?
Oh, thanks very much. I think it's a great question. I think one of the things really is how can we use the opportunity to build on existing technologies and develop the understanding from what we already know. I think being clear about our current pain points and what we want to address will help us identify those solutions and new technologies when we consider the tailings process end to end and consider a whole system. I think one of the challenges that we have is the tailing properties change spatially over time, and they require constant review against targets to ensure we have meaningful metrics that link to preventative controls. And when we talk about risk management, how do we move from looking at understanding a historic performance to proactively managing, predicting performance in the future? So I think we can build on what we know already, but the criticality is leveraging that information in a different way. And when we're leveraging it, I think that's really where, when we talk about being smarter, it's not necessarily sometimes using new technology. The technology is already there. It's just about applying it quicker and accelerating its implementation. And I think what we're starting to see is a pull to see our tailings performance in real time and see that transparent performance. I think there are so many variables and interdependencies. I think this is where we can really start to help ourselves. And I think the opportunity really is to start building those opportunities to be able to deliver an accelerated implementation of different technologies, rather than which historically been a bit slower approach to changing the way that we do our work because of the risks that are associated with managing tailings.
And Ken, your thoughts?
I agree with Dan. Much of the existing equipment has been around for quite a long time and is quite well proven. But over time, ore bodies have gotten to finer grinds. Some of them have gotten higher tonnages to deal with those lower grades. Mineralogy has got more complex, and it has led to a lot more variability. And that's where the smarter technologies really it's taking and building upon existing technologies, linking them together where you have more inputs on what's actually going on in the process to better control the equipment. So you get a much more consistent outputs. And newer technologies have gotten everything. It's similar technology. It's gotten bigger, larger diameter thickeners, bigger filter presses, these things have had to have their own improvements mechanically, but I think the big step forwards are going to be the interlinking of the process data around them, as well as really asset monitoring to let you know when you need to work on them. This optimizes the system's availability and leads to a better controlled system, which will give you more reliable results.
Priscilla?
Okay, so to me, the technologies that we have and the understanding that we have generally come from other fields. So the idea of materials management, the ideas of mining as an industry, effectively outsourcing the tailings management to a co-opted group of civil geotechnical engineers has resulted in technologies being brought over. But to me, the tailings are a different material. And so I think that for the future use of existing equipment, we really have to understand the mechanics of the tailings as distinct from mechanics of soil or as mechanics of any kind of particulate material randomly. We've got, as Dan said, quite spatial variability, temporal variability, as Ken referred to, in the tailings feed that's coming out. And we don't characterize that extremely well. If we did have real-time characterization, we might be able to make some different decisions about where to place or how to manage. And we need that kind of spatial and temporal variability in order to understand how to optimize existing thickening or filtration systems. I think filtration's coming on. I call it an existing technology. All it's doing is getting bigger. It's like the dinosaurs in the end of the Cretaceous. They were just getting bigger and bigger and bigger because this is the silver bullet. But it's not the silver bullet. It works really well in some cases, and in other cases, probably it shouldn't be tried. I don't think we know the limits of it. The big problem is getting the water out of the tailings, because if you do that, the tailings behave more strongly, better behaved, and the water can be returned into the water balance management on the site. So it's extremely important. And I think we have, in addition, to look at everything we do about getting the water out is really focused on using gravity or pressure, some kind of physical system that's actually going to get the water out. I think it's time to really move to electrokinetics and actually use an electrokinetic gradient that actually will drive the flow. This is not new technology. It's been around for decades, but it's really never had this really large-scale pilot operation. And I'd be interested in thinking about electrokinetics, combine it with some of the thickening operations, and even to look at the material that's in the impoundment, the tailings slurries, to be able to in situ thicken in the ponds very effectively. So I think there's technologies that we can bring in if we think, as Dan pointed out, as a systems approach. We could actually think differently about the materials that are there. And we made the materials, so we can change the way we make them, and we can change the properties that they have if we understand what the properties are that we're after. So I think it's being driven by Brumadinho, but it's an extremely exciting time in the mining and tailings management industry right now. We can see things coming out that actually make mining the golden industry for climate change, carbon sequestration, everything else, if we do it right. And I think mining can make contributions that it doesn't even have in mind right now.
Does anybody have any further thoughts on this before we move on to talking about practical case studies of new technology implementation?
I think one of the things that really resonated with me is both what Ken and Priscilla said is leveraging technology faster and accelerating its adoption. I think how do we do that is a critical question, and how can we set ourselves up for success? And I think, as we've all been talking about, leveraging that understanding and ensuring that we've got our performance mapped out, we're leveraging that data that we have available, but also we understand the criticality of the data that we've not got. It's very easy now to acquire the data that we need, whether it be through sensors, drones, satellites, that help us then de-risk pilot projects to be able to start trialing and testing new technologies. And as Priscilla said, we're in a wonderful space at the moment with metal and mining powering the energy transition. So we have a wonderful opportunity to really develop our technologies and try these out in a safe and sustainable manner.
Yeah, and to follow that through, you brought back up the idea of metals. I mean, we have a lot of tailings that we don't know what they are in terms of being a potential source of critical metals. And I think that the opportunity is there to find out so much more about the tailings that we have already in the past, legacy tailings that we're producing today, and then to understand how processing actually might be modified to change the character of the tailings in the future so that they're less problematic and more useful.
Yeah, I agree with that, Priscilla, especially when you look at the push now within the industry to what can we make of the tailings that may be an alternate use of it. One, it creates an added value stream, but it also reduces the amount of tailings in storage. And I think a lot of the unknowns with old tailings is due to just a lack of characterization, a lack of data. And so the industry as a whole needs to use the smarter technologies, all the sensors, everything that Dan mentioned to not continue putting out tailings that we don't know about, on top of going back and characterizing the older tailings. And how do we develop a process using existing technologies, do the gap on what technologies need to be developed to be able to better reprocess or even old tailings, process new tailings to create a better product for everybody.
So I'd like to explore some of the things you mentioned again towards the end of this panel when we'll discuss, we'll look forward to the emerging technologies or what technologies can merge in, or will emerge in the tailings arena. But first I wanted to ask, from a practical sense, how are you all observing new technologies being used to improve tailings management? Priscilla, maybe we'll start with you to share an overview of the top technologies you're observing in the tailings arena.
Sure. I'll give you my thoughts, but I think that the context that's important is the one that Dan introduced, when you have to think of this as a whole system. So I think of it as the geometallurgy, the material flow from ore body to tailings, and everything we do affects it. So I think we can go upstream all the way to reducing the volume of tailings. People are thinking about selective mining, in situ mining, where you actually do not move the material that is waste. In selective comminution, processing, sorting, maybe in pit or underground, take only the ore and leave the waste. So people are thinking about that. And I actually think there could be electrokinetic assists for that in situ mining, and changes the whole thinking about it, because you're mining down in the saturated rock instead of up in the dry rock, which is where mining people tend to want to be, in the drier rock. Mineral processing, we have dry grinding and sorting. We have the drive towards coarser grinding, the drive towards reducing water, and recycling, reuse of reagents. There's a lot of things that could be done in the processing. And this includes even something like microwave technologies that are being used to really, in some cases, very strongly, selectively comminute or break down the material, and if the ore is right, in such a way that you can actually extract much more effectively without going down to the extremely fine grain sizes. But with stoping, low grade mining ore, we're always going to be down in the extremely fine tailings that are very hard to manage, unless we can go upstream and take a look at exactly what those low grade ores need to be processed with. I've talked about electrokinetics before. I think filtration needs to be rethought, so it's not just a gravity or pressure physical driving. And as Dan talked about, the idea of multispectral satellite-based imagery, I think we've only just touched it. And from the standpoint of understanding how the tailings embankments and the tailings impoundments are changing over time. It's a dynamic process. We have rainfall, we have other things happening. If we're watching very carefully, the impoundment and the dam itself will tell us how it's behaving to changes in water content. And this is extremely important for us to understand, but we have to think about it over the longer time frame as a time series thing. And this brings in geophysics, because I think the whole application of geophysics is underutilized in trying to characterize what's going on with tailings. Also in pipe measurements, I mean, there's a lot of possibilities. Somebody just has to put some money towards the work of applying those things rather than putting the money in the pocket or buying more filter presses. Sorry, Ken.
Well, on that note, Ken, what impact are new solutions or innovative ways of thinking about older solutions or upgrading older solutions, such as the dry stacking solution co-developed by your company for higher tonnage mines? What impact are these solutions having on early adopters?
So, yeah, I think some of the challenges that we're seeing in the past with going above, say, 30,000 tons per day was just the sheer number of filters, sheer number of thickeners that would be needed. Just it became too much process equipment to handle and control. So, I mean, we've worked, and the industry has worked to develop larger filters, which reduce, obviously, the number of filters and their associated costs, including installation. So it is, I think, to Priscilla's point, I mean, the filters necessarily aren't the silver bullet for every mine site. Every mine site is unique, and you need to look at what the extreme characteristics, the ore body characteristics, and once you understand that and you treat the system all the way from the beginning to the end, and sometimes with tailings you need to start at the end and work backwards to look at, once you understand the target that you need in your tailings area, you look at, can you achieve it with just cyclones and pumps? Do you need to thicken it? Do you need to filter it? And if it's a large tonnage mine, you need to look at looking at larger filter presses to understand their cost. You need to look at how you're going to handle the material after it's filtered, whether, different types of conveyors, whether the belt or pipe conveyors, the type of stacking system that you're going to use, how that is affected by the terrain. And then a lot of that emphasis on that has helped the early adopters who are now purchasing or as well as investigating these larger filters is, once you've bought it, how much does it cost to run it? So we've looked at more effective plates, only looking at changing out wear parts, wear inserts on the plates, the media, extending media life. You have to look at every nook and cranny of the system to really bring down those costs. And then once you've got the mechanical side, I think it's not just, we in the equipment side tend to look at, the controls on our equipment and using the data, but I think, again, you need to look at from front to end, how are those systems connected, not just by pipes and wires, but through a control system that can take in an extreme amount of data and use it for controlling, to make sure we're not just producing the concentrate that we want for profitability, but we're producing the tailings that's going to meet the storage area's requirements. And so there has been a lot of development in the digitalization area, and it's a huge emphasis right now. But I think it's going to take a very large group throughout the entire industry to tie it all together.
And speaking of digitalization, you're providing good segues here. So speaking of digitalization, Dan, obviously that's OREN's area of expertise. So can you talk us through the impact that digital solutions specifically are having on managing, or can have on managing, performance and risk at tailings facilities?
Yeah, and I think we've already touched upon it about really being transparent about our performance, number one. Yeah, really end to end, what does that look like? And then really, where are our problems that we want to improve within that process? And then we can really hone in on what do we want to do about it. So I think in that space, we're really moving into real-time monitoring. And I think that's where we start getting from real-time, and we're starting to see things coming into the predictive space. okay, the what if scenario, what's going to happen, what are our risks, how do they potentially evolve over time as our variables change. And I guess what we're seeing very much in this space is that, you know, optimal strategies are very much site specific. You know, those physical and chemical characteristics of tailings change again with the process methods, topology, the climate conditions, and even the regulations in that country itself could be different. So we're starting to see then, with those changing dynamics, people want to see how we're performing now. And we mentioned before a little bit about, you know, aggregating solutions, and we're starting to see kind of digital solutions not just work in isolation. We're starting to see them starting to work in combination, and that's particularly where the OREN tailings solution comes in, with aggregating proven digital technologies, whether that be sensors, advanced analytics, all the way to a digital twin. We're seeing a pull that digital solutions are really helping to model and analyze risk, but more importantly, predict it to make those risks transparent to a wide variety of stakeholders internally, but also more importantly now externally, of making sure that we're operating, but we can show that we're operating safely and sustainably.
So let me do one thing I want to say is that, yes, everything is site specific, but there are some fundamental things that we don't fully understand in the behavior of the overall system. And I think everything's treated as one-off application with everybody doing something locally. The information is not shared. We're not building a fundamental understanding. So I think there's an opportunity here in the next 5 to 10 years to really, what I call building the practice of tailings engineering as a profession. And this is really not just borrowing from Peter to pay Paul. This is really fundamentally putting down the mechanics of how these tailings behave. And you brought up a diagnosis of problems, Dan, and I think that's incredibly important for a whole systems approach. But one other thing is that one of the major problems we have with tailings and risk is the potential for what is called contractive material, the potential to develop sudden failures in the material, in the tailings embankments. We made those tailings embankments, we built them, and we don't know what we did to make the material contractive. And if we did know, we could stop doing it. And if we could find where material is contractive, maybe we could develop new technology to actually take care of it and in place remove the contractive nature. So I think there's lots of field savvy building, field measurements that we need to do to understand what we have done. Before we start trying to change things for the future, let's really understand the way we're doing things now more effectively so that we can look systematically at how do we change it in the future to know that we're reducing risk.
Yeah, I'd like to touch on a point as well with that, Priscilla, that, you know, the new guidelines and standards that are being released are calling for a lot more transparency. And I think that, you know, the push to better understand and monitor and record and have all the sensors in place, feeding into a larger control system will enable that transparency without it just being a nightmare for the sites to manage. Because if you look at the past, one of our biggest problems has been publicly available data about the industry. You know, it's very difficult. We've done research projects with universities, you know, and students have spent weeks looking through, you know, public documents trying to find, you know, information, and it's not available. A lot of that information is difficult to get without proper sensors and everything else. So, you know, the hope for me is that as we move towards these smarter systems, the data is more readily available to be transparent and publicly available. So as an industry, we can pull that knowledge together to learn.
Let me just follow through on that thing, because you're 100% right, Ken. But a sleeping tiger in this is the workforce that's actually going to be able to do this. And we have significant workforce problems in the mining industry, and the mining industry is largely disengaged from academia. So we have almost no faculty doing research. on tailings. We have almost no universities in the United States that are teaching anything about tailings, so the students are not coming out. And unless there is a connection, and this data and the transparency has the potential for being a connection where faculty can look at real data, can decide, I'm going to spend part of my career messing around with data on tailings and see what kind of contribution I can make. Then they will teach courses, they will produce students, and we will have the workforce. We have to create the pipeline because it's broken right now. And this whole discussion here of new technologies, if we do it the right way, we can recreate a pipeline that the industry needs for the future.
Agreed.
We like to end panel discussions on a forward-looking note. So the questions I would put to you all are, what types of new technologies can we expect to see emerge in the tailings arena in the years to come? We've discussed a few of these. If you're able to elaborate on those. For example, will we see increasing digitalization or perhaps something out of the box that isn't yet well known? What aspect of tailings should technology developers be focusing on? For example, should they be addressing water usage? Priscilla, you spoke earlier about extracting economically viable resources left in tailings facilities, which we don't know a lot about, or are there other aspects of tailings that tech developers should be looking at? Ken, why don't we start with you for this question?
All right. Yeah, I mean, I think as we've kind of been the consistent trend, we need to look at a systemic or a holistic approach to how do we in the mining industry, go towards lower emissions, water usage, power usage, to become a more sustainable and really responsible industry. I think when it comes to tailings, you have to not just look at the tailings themselves, but the overall, process to generates the tailings. One of the variables that or characteristics that affects the tailings quite a bit, both in the processing as well as the way it behaves, is the amount of fines. So if we look at how do we reduce the amount of fines through, say, dry grinding, high pressure grinding rolls versus vertical roller mills that are known to produce fewer fines, that leads to not just better tailings, but better processing. We often lose the valuables that end up in the ultra fines. We can look at dry classification. Then those combined with then allow you to do coarse flotation, where you're separating out your coarse valuables. You're reducing the amount of material that goes through a traditional process that may need newer flotation technologies, reflux flotation, to pull out more of the valuable, increase recovery. And then when you tie it all together, those basically better engineered tailings dewater better, they behave better, along with the digitalization, leads to an overall system that is lower power, lower water, lower emissions, and it's just easier to control. I think in the future, what we want to look at too, to keep the industry moving forward, is maybe some more of the creative tailings storage facility designs. We look at different ways of handling the tailings, whether it's splitting into coarse and fine streams or combining even certain streams. There's look at, and what we call the jelly donut, where you have very dry outer shell and you put some gooey stuff in the middle. So you still have stability. There's just, in the past, we've treated the storage facility as a one target for the entire 100% of the tailing stream. And if we can get a bit creative, we can look at how do we achieve what is needed at a given site while maintaining a sustainable mining model.
Dan, your forward-looking thoughts?
Yeah, I think we've touched upon it already around, getting that transparency around performance. It starts with our current understanding, and then we look at that proactive, predictive, what does that mean to us? Because it opens up not just how we change our process, but also what new opportunities we have within the process to look at it completely differently. I think when we look ahead, I think partnerships are coming in. How are mining companies partnering and leveraging their data? What does that look like? I think there'll be more collaboration that comes in the future around tailings. particularly what can we do with getting the right information to understand that performance. I think when I specifically look at digital, what we're seeing is the combination of digital technologies rather than isolated solutions. You're looking at solutions coming together that combine sensors, analytics, visualization, automation, and predictive capabilities as a single solution, but not provided by one solution provider, aggregated together towards one solution. And I think as we move in that space, we're going to be leveraging that understanding from different areas, different businesses to really accelerate mining. And for me, when we look forward, I think we need to start looking at how we work better together with those outside of mining, because they also have a lot of creativity and innovation of applying solutions that we may have no idea about that could solve some of our problems. I think if we get the right data sets to them, we can then excite them to be able to come and work and also play in this space, because we need it to be fun, and we need to start with how can we be at the cutting edge of that type of innovation. And for me, it all starts with our data, enabling those digital solutions, which then hopefully translates into trialing new and innovative technology.
Priscilla, I know you've written about this as well. What can we look forward to in terms of tailings technology development?
You know, I think it's the critical need is to, one of the critical needs is to really understand the characterization of the tailings and the water more effectively over time and space. So this is going to drive really getting mining into the circular economy. Right now it's sitting outside. Very few mining companies think about downstream diversification. So you're thinking about materials flow and recycling, but also responsibility flow, because ESG, responsibility aspects, are going to be extremely important. And when mining companies can sit and look at their tailings and say, what are, do I have critical minerals? Can I remine this stuff in situ or passively or actively? Can I get entrepreneurs interested in the use of my tailings? Can I think about alternative uses, whether it's geopolymers or, I mean, I think we can even go to the analogy of melting basalt rock, where you can make basalt fibers. You can also melt tailings and produce a glass. And what could you do with that glass? Lots of things. So I think there's this, once we understand the material better, we can use it. I think automation is huge. It's going to be taking over pretty much every automation function in the world. And we're going to increasingly deep mines and deep operations. So that's going to drive the increase in automation and digitization. Very few mines have actually closed some of these major tailings storage facilities that have been built. And that is a whole nother world of how do we monitor, how do we understand the long-term performance of these huge TSF facilities that communities and the social license demands be closed at some point, and what will closure require of instrumentation and monitoring. But we also have some fundamental questions about tailings material behavior long-term that I think needs to be handled. The effects of the mineral processing reagents, the additives that happen, affect the measured strength of the material. Now, we haven't really investigated that. A little bit of work out in Western Australia has done some testing showing that if you test the tailings with the reagents in place, you get a different strength from that which if you test it with pure water or laboratory water. This is a problem. Let us find out what the answer is. I talked about contracted materials. We need to figure out where they are, and then we need to develop technologies that will do something about it. Our tailings dams are getting higher and higher, 300, 500 meters high. We do not have earth embankment water retention dams anywhere near that. So we are beyond stresses that most laboratories can even test. This is a new material being stressed to new levels. We have to do some fundamental work about this. And I think characterization of legacy facilities and any retired facility, if we can't characterize what's in them, we do not know how to take them down. We do not know how to declassify. And this is a major problem with the rules of Brazil that has now in place. They have to figure out what to do with the existing tailings dams when they don't know what they are. So it's really a fundamental characterization that we need. And this requires really almost Green's function approach to the characterization of functionality, of starting off by asking yourself a question: why hasn't this tailings dam failed yet? Do I know? And if I don't know, then I better try to do something about it. And finally, about compaction. The idea of dry stacking and compaction, it's compelling in some environments, but you put climate change on top of that, I will guarantee you that dry stacks will become saturated. And we do not know the behavior of that compacted material with its spatial variability on saturation. We do not know. So we could be making compactive dry stack lifts that are just sitting there waiting to become contractive on saturation, and we don't know. So we have to stop doing things that we don't know.
Would anybody like to add any closing thoughts or responses to what was said before we wrap up?
Well, yeah, I mean, I'd add that I think, what we've been discussing in the future of tailings and mining in general, with the push towards smarter solutions, will hopefully have a bleed-on effect to filling the pipeline and taking care of those problems that Priscilla mentioned earlier. That I think in the past it's been difficult to get people interested, young people interested in the industry. It's seen as an old industry, not very interesting. It's, but as we move into the digital age, kicking and screaming at times, I think the hope is that we will get the younger generations that have a much more diverse background, bring new ideas, and allow a positive effect, not just on, the labor pipeline, but the idea pipeline, and will bring those new ideas that actually help us become a better industry because we have newer ideas and we are able to now solve the problems and better understand where we're going in the future.
I think just to add to that, and I think just to echo what everyone said, increased transparency and understanding is going to help us deliver the sustainability that we all want to achieve.
Yeah, and I was thinking, because both of you, I think, have chemical backgrounds, chemical engineering backgrounds. One of the biggest unknowns really is, over time, how does water, acid mine drainage, how does this evolve? And can we manage it? And this is a major question for closure, and it requires long-term measurements of a chemical variety. While we're measuring everything else, we need to follow the chemistry. And we tend to think here about metals mining and the huge volumes, but I think we got to look around and see some other materials that are causing problems, like phosphogypsum. Phosphate mining is huge, and phosphogypsum, with the processing that we do, concentrates uranium, thorium in the waste material. And now what the heck do we do with that? So we can think about metals mining, but you look at other kinds of mining, whether it's red mud or phosphogypsum, there are huge chemical issues that may well be biochemical. And so you think about the influence of biology in all of this. This means that when we're looking for people to engage the mining industry, we're just not looking for mining engineers and civil engineers. We want data engineers. We want chemical engineers. We need biological engineers, because what we're really doing is we're building a concept of stewardship of Earth's resources. So we're thinking about how do we make sure that mining is known as a steward, where there is no waste. All things are used, and we understand what we're doing. We can get there. So it's a very exciting time in the future, but it's that acknowledgement that there is a call for stewardship, which is noble purpose, which will really attract this upcoming generation into the field if we say it right.
a great note to finish on. Dr. Priscilla Nelson, Colorado School of Mines, Dan Leybourne, OREN, and Ken Rahal, FLSmidth. Thank you for a very interesting panel discussion on tailings technology.
Thank you for the opportunity.
Thank
Enjoyed
you.
it.
It's been wonderful.
Thank you.